Welcome to students for the lecture 3. In this lecture, we are studying about even and odd signals. Few more examples we'll be looking into than the things what we have solved in the previous class. And we'll be studying periodic and non-periodic signal classification. And today we'll be having a lot of example solving, and I would recommend you to have a pen and notebook in order to practice hand in hand with me in this video. With this, we will start the session of today's lecture 3. So then, today's topic that we are covering are few more examples on even and odd signals and periodic and non-periodic signals. So I have solved around 2 examples in the previous class. So in this class, I'll continue from the third example. Third example. So given signal is x of t, which is equal to 1 plus t cube cos raised to 10t, cos t raised to 10. So here you need to find out the even and odd component of this equation, given equation. So let me call it as equation 1. So the very first thing that we need to do is you need to extract what is x of minus t. Replace t with minus t. So if I do so, I would get it as cos raised to 10 of minus t. So if you solve it, minus t cube will result in 1 minus t cube. So cos of minus t is cos t itself, hence it's just cos t. So this is x of minus t and I name it as equation 2. Now we know that xe of t is given by x of t plus x of minus t divided by 2. So when I add 1 and 2, I would get cos of raised to 10t taken common 1 plus t cube. I have to add it 1 minus t cube. So I'll divide it by 2. So t cube and minus t cube cancels. So I will get it as 2 into cos raised to 10 of t, because 1 plus 1 is 2. So that 2 and this 2 cancels, and you will get even component as cos of t raised to 10. Okay. So similarly, to extract odd component, the equation goes like this. We have already studied about these things in previous class. So same thing, cos raised to 10t, I'll just take common. 1 plus t cube is x of t minus 1 minus t cube. So it is 1. So this minus into minus will result in plus t cube divided by 2. So 1 and minus 1 cancels. T cube plus t cube is 2t cube. 2 and 2 cancels. So you will get it as t cube cos raised to 10t. 10t. So this is your odd signal. Odd signal. So you can verify this. So if I add x or xe of t and xo of t, I would again get back the original signal. So hence, so this extraction of even and odd component is perfect. Now similarly, I'll take one more example. X of t is equal to cos t plus sin t plus sin t cos t. So xe of t is what here? You can directly say that whenever there is a cos component, that should be a even component. Whenever there is a sine component, you can check it. I would rather suggest you to proceed with these all formulas and come to the conclusion. So you can verify it later. So if even component is cos of t, the rest of the remaining component of the given signal should be odd signal. So I copy it as it is. So this is the fourth example. I want you people to solve it in with formula. Solve with formula. You can do it because it is simple problem. So I would suggest you to solve it by yourself. Yes, students will have example, a different kind of example now. I'll take an example now. X of t is equal to a into e raised to minus alpha t into u of t, where alpha range is within 0 to 1. Let me tell you what's the meaning of u of t right now. So in detail study of u of t, you will be doing it later. Just right now, you just understand that u of t is nothing but t greater than or equal to 0. That's it. Okay. So now here we need to extract even and odd component of this. Or in simple, if I want to write it, I would write it in simple as x of t is equal to a into e raised to minus alpha t for t greater than or equal to 0 and 0 for t less than or equal to 0. This is what's the meaning of u of t. Okay. So now the very first thing is I need to replace t with minus t. So what do I get? So minus t, if I put it here, it becomes alpha t. So alpha t, and similarly here minus t greater than or equal to 0. Okay. So here 0 for minus t less than or equal to less than 0. So what is the meaning of this? The meaning of this is this. So whenever you have minus in this place, you just invert the relational operator. So invert it, you'll get it in this way. Okay, you're like putting a NOT gate. So here also I'm having minus. So and the meaning is t greater than or equal to 0. So this is how you need to write. So I am having x of t and x of minus t now. So with this, I can go for finding out xe of t. Now, for finding out xe of t, I need to consider two cases. Case number one is, I have two cases here. Case one is t less than 0. Case 2 is t greater than or equal to 0. So first, let us consider case 1. So case 1 for t less than 0. So in this case, the even component is xe of t is addition of x of t and x of minus t. You consider only this one now, this one and this one. These two are t less than 0, t less than 0. So x of t is plus x of minus t divided by 2. So what is x of t? X of t is 0 plus x of minus t is a into e raised to alpha t divided by 2. So hence your answer is a by 2 into e raised to alpha t. So this is your even signal. Then what is odd signal? Xo of t within this range itself, in case 1 itself. X of t minus x of minus t divided by 2. So here it is again 0 minus a e raised to alpha t divided by 2. So your answer is minus a by 2 e raised to alpha t. So this is these two things for t less than 0. For t less than 0. Now we'll compute the same for case 2. What is case 2? Case 2 is t greater than or equal to 0. So t greater than or equal to 0 means, let me take let me change the color for your understanding. So I'll take greater than or equal to 0, greater than or equal to 0. So xe of t, I don't write the formula again. So here x of t is a e raised to minus alpha t. Xo of t is 0 in that range. So you will get it as a by 2 e raised to minus alpha t. So this is your even signal. And odd signal is a into e raised to minus alpha t minus 0 divided by 2. Hence you will get it as a by 2 e raised to minus alpha t. So you'll get almost in the same manner, uh, x naught for odd signal and even signal in this case. So this is the odd signal and even signal extraction for this um, special type of signal. Okay. So now we will just check, take one more example. There is one function called a sinc function. So sinc function is, I'll take a blank screen. So sinc function means, sinc function or signal means it looks in this fashion. X of t is equal to sinc of t. This is t. So this would look like this. Same thing on this side. Okay. So sinc function is given by, sinc of t is nothing but sine pi t divided by pi t. So this is the definition of sinc function, is sine pi t divided by pi t. Now I want to extract even and odd signal out of this. Okay. So to extract, to decompose in even and odd. This is what we are doing now. So if I consider this as x of t, what would be x of minus t? Sinc of minus t. What is sinc of minus t? Sine, wherever t you have, replace it with minus t. Minus pi t divided by minus pi t. So sine of minus pi t is, minus sign comes outside, sine pi t divided by minus pi t. So it cancels. You're left with back as sine pi t by pi t. So it is as good as sinc of t itself. So sinc of minus t is nothing but sinc of t. So in this case, I can write x of t is equal to x of minus t. What this condition resembles to the condition of even signal. Hence, this is a even signal. Whole sinc of t is even signal. It's a even signal. So, and what about odd signal? Odd signal in this case is 0. So this is all about your even and odd signal. Take out certain assignments. Solve this. Take it as homework. First one, x of t is equal to 2t square minus 3t plus 6 divided by 1 plus t square, or 1 plus t. Just take it as 1 plus t. And second one, x of t as e raised to jt. This is second one. So you know that Euler's formula. By Euler's formula, I can write it as cos t plus I sin t, I or j sin t. That's second one. So now we will look into the periodic and non-periodic signal. Very important topic. Very important topic. Periodic and non-periodic signal. First, we'll understand what's the meaning of periodic signal. A periodic signal, x of t, is a function of time that satisfies the condition which is given below. X of t is a given signal, and to satisfy the periodicity, it should get equated with x of t plus t, and for all t, and this t is a positive constant. This positive constant we also denote it as a period. So t is a period. So you should be very much familiar with the terminologies that we use. So here I have taken a piece of a waveform sample. You can check here. So x of t across the y-axis, and across the x-axis it is t. So the signal looks like this, and it is not repeating. Hence it is non-periodic. This is aperiodic. Non-periodic or aperiodic means the same. Whereas in this signal, you can see that after every time t, the same signal is repeating. So this is for the first time t, this is for second time t, this is for I can write it as t, this is again next t. So here also it is for the same amount of time, the same signal is repeating, first, second time repeated, third time. So continuously it will be repeating in the same fashion. So this kind of a signal will be called as periodic signal. This is a periodic signal. So you will be asked with certain things like we will be giving you the given signal, and you need to identify whether the given signal is periodic or non-periodic. And to check it, you need to use this case for finding whether it is periodic or non-periodic. So here, as I've already said, we'll be making use of frequency, and the denotation used is f, which is a reciprocal of a period. F is nothing but reciprocal of period. And this t, we normally call it as fundamental period. We call it as fundamental period. And thus f, we call it as fundamental frequency. We call it as fundamental frequency. So this is how we need to call f. And there is one more variable parameter called w or omega. We call it as omega. Omega is given by 2 pi f, and this omega we call it as angular frequency. Angular frequency. Now I am discussing all this keeping in the mind the continuous time. So continuous time signals, periodic signals we are studying, because wherever I have made a reference of waveform or the signal in terms of mathematical functions, I've used t as a independent variable. And for discrete time, you should use n. For that, the things changes a bit. So for that, I'll take a screen, one more screen. So here, the discrete time periodic signal, I'll write it here. Discrete time periodic signals. Discrete time periodic signals look like this. For example, I'm having a discrete time signals in this fashion. One at, it is 1, this is half, this is again 0, this is 0 at 2, 3, 4, 5, and at 3 again it copies from 0. This is half, this is 0, and again continues same thing. And here also -1, -2, -3. So it is 0, it is half, and this is 1. So it continues. So you can see that after some interval, let me call it as capital N, your signal shape is remaining same. So then this is called periodic signal. This is called periodic signal. And the condition for this is x of n should be equated to x of n plus capital N, where capital N is a positive constant and it is an integer, positive constant, positive integer, I can say, positive integer. And for aperiodic, so this will never repeat again. This will never repeat again. And here the angular frequency denotation is a small omega. This is also called as omega. It's a small omega, 2 pi by capital N radians. The SI unit used to denote it is radians. So this is a periodic signal and a periodic signal. A periodic signal is the one which does not repeat. Okay, so we will have some example here. I'll just show you. Think that this is a continuous time signal. here also it repeats, it continues. This is 0, 0 0.1, 0 0.2, 0 0.4, 0 0.6. So it goes on. So now you can see here at every t is equal to 0.2 seconds, at every t is equal to 0.2 seconds, your signal is repeating, and 3 dots here indicates that it is repeated continuously indefinitely. Then it is a periodic signal. I'll take one more example. It is x of t, this is t, and I'm not mentioning any t here, dots here. So it is only a rectangular pulse. So hence it is not repeating. It is a non-periodic or aperiodic signal. Non-periodic or aperiodic signal. I have some examples in front of you in order to make our analysis much more effective. So here I have a signal. You please have to identify whether it is a periodic or non-periodic, and you can see that this signal is repeating after every 0.2 seconds, after every 0.2 time period. So hence it is a periodic signal. It is periodic signal. What about this? It is not repeating, hence it is a periodic signal. But this is a continuous signal. Even this is continuous signal, but it is aperiodic. What about this? This is a discrete signal, but you can see that after every 0 to 7, from 8 again it is repeating and dots have been put. Hence it is periodic signal, but it is a discrete time signal. It is a DT signal. Here the question asked is what is the fundamental frequency? What is the fundamental frequency, and express the same in hertz and radians per second. So here what I have to do is we decided that x of t is a periodic signal in the first case. Now what is a fundamental period? Fundamental period here is, you can see that this is going to stay for 0.2 seconds, again for 0.2 seconds it is repeating, and again for 0.2 seconds it is repeating. Hence t is 0.2 seconds. This is your fundamental period. But we have been asked to find out fundamental frequency. So what is fundamental frequency? Its denotation is f. F is reciprocal of period. So reciprocal of period means 1 by 0.2 seconds. 1 by 0.25 seconds will give me 5 hertz. This is fundamental frequency. To express it in radians, I need to compute its angular frequency. Angular frequency is denoted by omega. So omega is 2 into pi into f, hence 2 into pi into 5. So you will get it as 10 pi rad per second. So in this second case, this is for first case. This is for first case. So in the second case, it is aperiodic. So there is no period or fundamental frequency. So that no question of t and f. Okay. So for the third one, so it is a discrete time signal. Hence you will have to call it as n. You have to call it as n. Identify. So from here to here, it is 0 to 7. So total n is 0 to 7 means 8. 0 also you should take into account. From 8 to there on, again n is equal to 8. So after every 8 samples, your signal is repeating. So hence n is equal to 8. So now here the angular frequency, you can call it as angular fundamental frequency because there is no f kind of thing here. This is denoted by small omega 2 pi by n. So it gives you 2 pi by 8. So it is pi by 4. Just you have to write radians. So this gives you the answer for the asked question 1, 2 and 3. Now we will look into further more examples. Let me take next example now. The next example is determine whether The following signals are periodic or aperiodic. You need to find whether the given signals are periodic or aperiodic, and also you should find the fundamental frequency if it is periodic signal. The first signal I am taking into the consideration is x of t is equal to cos square 2 pi t. So you should check whether it is periodic or aperiodic and find its fundamental frequency. These are the questions. So what is the solution for this? Solution is, we know that from the trigonometric basics, cos square theta is given by 1 by 2 1 plus cos 2 theta. We have already studied this. We apply the same thing here. Cos square 2 pi t is given by 1 by t 1 plus cos 4 pi t. 2 into 2 pi t is 4 pi t, cos 4 pi t. Now we will start with periodicity's condition. This is periodicity condition. So what's the periodicity condition? X of t should be equal to x of t plus capital T. So here cos square of, I can write this one. This is my x of t now. This is my x of t. So replace replace t with t plus t in the next equation. So what happens? 1 by 2 1 plus, here also I'll write x of t means 1 by 2 1 plus cos 4 pi t. So at this place I need to replace it with t plus t, cos of 4 pi. So in this place t plus capital T. Now 1 by 2 1 plus, I would get it as cos of 4 pi t plus 4 pi capital T. We know that whenever we have something like this, cos theta plus 2 pi, it results in cos theta itself. This is a property of cosine signal and sine signal. Or sine and cosine are periodic with period 2 pi. That we know it. We want to extract the same thing from this trigonometric basics. If I equate this 4 pi t to 2 pi, then we'll come to know this signal's periodicity. So for that, what we are supposed to do is, we have to equate 2 pi with 4 pi capital T. What do I get? T is equal to 2 pi by 4 pi. So pi and pi cancels. You will get it as 1 by 2. So 1 by 2 seconds is your T. And the answer, the understanding from this is, signal x of t equal to cos square 2 pi t is periodic with fundamental period t is equal to 1 by 2 seconds, and fundamental frequency is given by 1 by t, which is 1 divided by 1 by 2, which is 2 hertz. That's it about your example. Now we will just go to the next example. I'll take one more blank screen. So next example B is x of t is equal to sine phi u t. So find its periodicity. For that, you have to apply the condition. What is the condition? Condition for periodicity is x of t should be equal to x of t plus capital T. So sine of phi t should be equal to sine of phi. In place of t, what I have to do? T plus capital T. This is nothing but sine of phi t plus phi capital T, right? So we have to equate phi t with what? 2 pi, because we know that sine is periodic with 2 pi as a period. So hence t is equal to 2 pi by 5 seconds. So this is the fundamental period. I can say this as fundamental period. And fundamental frequency is just reciprocal of it. Now I'll take one more example. X of t is equal to e raised to minus 2t cos of 2 pi t. So what I have to do? Apply the condition, or you can directly start, because we have already witnessed that what is the condition. Replace t with t plus t, e raised to minus 2 into bracket t plus t cos of 2 pi in place of t, t plus capital T. So I will get it as, I'll get it as e raised to uh, what we are supposed to do here is, first I have two components here. I have two components here. Let me take this component. So this component, if I open the bracket, I would get it as 2 pi t cap plus 2 pi capital T. Now for periodicity, I need to compare it with 2 pi. So 2 pi is equal to 2 pi t would give me t is equal to 1. Would give me t is equal to 1. The same thing I'll apply for the second case. The same thing I'll apply for the second case. What do I get? Minus 2 t plus, one second. I would get t plus, so this is already decided 1, or else this component becomes minus 2t minus 2. So this is not a periodic signal. Even when you multiply it with the cos signal, this will not be a periodic signal. So it will not result in x of t, hence it is not equal. Hence this is a aperiodic signal. This is a aperiodic signal, because you cannot get back. You cannot get back with even if I place, even if I place 2 pi in place of this, I would not be able to get back the original signal as e raised to minus 2t, because of existence of this particular component. Hence it is a periodic signal. And this is periodic with fundamental period t is equal to 2 pi by 5 seconds. This is an example. Now I'll take one more example. I'll take a discrete example this time, discrete signal this time. Minus 1 raised to n. Check whether it is periodic or not. So what we are supposed to do here is, first the condition. What is the condition? X of n should be equated with x of n plus capital N. So here it is minus 1 raised to n. This is minus 1 raised to n plus capital N. Also I can write it as minus 1 raised to n minus 1 raised to capital N, because if these things are same, then you can just add the indexes n plus n. So that's why I have written in this fashion. To equate with x of n, this should be retained as it is, but this should go off. To take it out, my concentration will be only on this. Now in the next step, I should make sure that this should go to 1. So if this should go to 1, if this goes to 1, I'll be left with only one component, minus 1 raised to n. Hence it becomes x of n itself. I can tell that it is periodic. So to make it 1, what should be the condition for n? This will be equal to 1, minus 1 raised to n will be equal to 1 only if n is even. Only if n is even. Hence, how to write it in mathematical function? So it can be written in this fashion: 1 raised to 2m. Okay, so where m is 1, 2, it should proceed. So hence n is equal to 2m, where minimum value of m is 1. So the fundamental period n is 2 into minimum value of m is 1, hence it is 2. So n is equal to 2 is the fundamental period. So what your conclusion is? X of n is equal to minus 1 raised to n is periodic with fundamental period n is equal to 2. That should be your answer. Okay, we'll take one more last example for today. That is E x of n is equal to minus 1 raised to n square. Now what we are supposed to do? X of n plus capital N. Replace n with n plus capital N whole square. So what do I get? Minus 1 a plus b whole square. N square plus 2n capital N plus capital N square. So in order to equate it with capital X of n, so these two terms I don't want. So I can write it as minus 1 raised to n square into minus 1 raised to 2n capital N into minus 1 raised to capital N square. So I want to take out these two components to make it equate to x of n, so that it can be told as it is periodic. So what I'm supposed to do? That's why minus 1 raised to 2n capital N minus 1 raised to n square should be equated to 1. So first I take it as minus 1 2n capital N plus n square should be equated to 1. So simple as we did in the previous case. So 2n capital N plus n square should be equal to 2m, because minus 1 off, because minus 1 raised to 2m is always 1 if m is a natural number starting from 1, 2 like that. So hence I'm equating it to 2m. So if I equate it to 2m, I'll consider it as equation 1. Now let me go with n equal to 1. What happens if n equal to 1? So what do I get? Minus 1, substitute n equal to 1. So 1 square, here it is 1, 2n plus 1 I get. So this would result me minus 1 raised to 2n minus 1 raised to 1, which will result in minus of minus 1 raised to 2n, which is equal to minus 1, which is not equal to 1. So this fails. Now I try with n is equal to 2. So you need to go with trial and error method. So what do I get? N equal to 2 means 2 2s are 4, 4n plus 4 square. 2 square means 4. Sorry, 4. This is equal to 1, 4, 4n. This is equal to 1 minus 1 raised to 4n. So you would get it as 1. This is correct. So hence fundamental period should be fundamental period n should be equal to 2 samples. 2 samples to make this signal periodic. Hence this signal is periodic. X of n signal is periodic. So this is all about periodic and non-periodic signal. In the next class, we are coming up with the lot of example solving in periodic and aperiodic signal. And if you go through the previously appeared question papers on signals and systems, there is one definite questions which is going to appear in from periodic and aperiodic signals. So with this, we are concluding the lecture 3. Thank you.